Hello guys, welcome to our new video tutorial series, and in this video tutorial series we will discuss about the CPU scheduling. So you have heard the term of CPU scheduling if you are a computer science student. And what is the CPU scheduling? So CPU scheduling is a process used by operating system to manage how computers manage different tasks called processes are given access to the CPU how the computer brain so that they can run, since a computer usually has many processes that needs to run. So the operating system decide which one gets to the CPU and how for how long. So how like we have the multiple processes at the same time. So how CPU knows that which task needs to be done for how long time and how it's done. So here comes the CPU scheduling. So, why CPU scheduling is important? CPU scheduling is important because it helps make sure that all processes get a fair share of the CPU. The system runs efficiently and no single process gets stuck waiting forever. So, it also ensures that important tasks get done quickly when making the best use of CPU time. So, why CPU scheduling is important? For example, like we have 10 processes at the same time, and the process 1 execute in 2 seconds, the process 2 execute in 4 seconds, but the process 3 will take like up to 10 minutes maybe. So in that case the other remaining processes needs to wait until the process 3 complete and terminate. So in that case, we have the CPU scheduling methods that will, allow all the processes to run and execute according to their priority or their, you know, time quantum of the CPU. So here comes the CPU scheduling works. So we have two different types of CPU scheduling in our operating system. The first one is non-preemptive scheduling. So, what is non preemptive scheduling? Non preemptive scheduling is a type of CPU scheduling where once a process starts using the CPU, it keeps running until it finishes. No further process can interrupt or take over the CPU during the time. The CPU only switches to a new process when the current one is completely done. So, in that case, like a process is selected to run on the CPU, the C process uses the CPU being interrupted without being interrupted. Once the process finished, the CPU is assigned to the next process in the line. So it's in that case like you are in a grocery store and you have a line, and they are like four people's before you. First you are the fifth one, and once the fourth one take their bill, and then your turns come up. So we just first come first serve. The first person came, and then it will execute, pay their bill, and then next turn. So without interruption, like there is no priority, like in that case, like you cannot, if you are a fifth person in a row, you cannot go on the first of the line and say that please, you know I have a urgency, please take my bill and let me free first. So it doesn't happen like that. So there's a small diagram process flow, which you can visualize. Like we have the three processes: process A, process B, and process C. So first the process A runs, then the process B runs, then the process C runs, and it will execute, no interruptions. Same like if we have a, like, there's a teacher in a class and five students, and um, teachers take their questions one by one. So the first student have like five question, second one has maybe 10 question, third one has fourth question, and the fourth one has five question. So first teacher can take the student one all the questions and then answer it, and then move to the second student, then third student, then fourth student. So in that case, if like student fifth, on the fifth number, he have only one question to ask, he have to wait until all the four students get free. So this is non-preemptive scheduling. Okay, so then there has come the preemptive scheduling. So what is preemptive scheduling? So preemptive scheduling is another type of CPU scheduling where a process can be interrupted before it finish. If another process is a high priority needs the CPU, the interrupted process is moved to a waiting state and the new process is allowed to run. So how does it work? A process starts running on the CPU. If it gets a higher priority process arrives, the current process is paused and moved to the waiting state. So the higher priority process uses the CPU. Once the higher process is done or paused, the original process may be resumed. So how does it work? So for example, the same example, you have a class of student, five students, and every student have like five questions to ask, for example. But a teacher say that I will, answer only two questions at a time. So first the student will, first student will go and they said, "Hmm, okay, give me your questions," and teacher answered their two questions, and the remaining three one will be a next turn. Okay, then there's come a second student, he will ask two questions, teacher answers, then student three asks a two question, and there's a next turn. Once the five student all two questions complete, then teacher move again to the first student and ask the remaining two questions. So in that case, the student the student on the fifth number will not have to wait for the entire student to free, and then he will ask if he had a one question, then he will be free. Like for example, a student fifth, on the fifth number, he had only two questions. Okay, so once the you know first the teacher asks the teacher answers all the questions of the student fifth, he will free. He will be free. He can go to next class or maybe his time up. So next in next cycle, all four students will have to be sit there and teacher have to answer the question. So and for example, in the same example, like if we have a five student and each student like teacher answers all the two questions at a time. So for and there is a high priority a girl came, the fifth the fifth are the male student, and there's a girl came and she asked very politely, Professor, please answer my question. I have only one question. I'm getting late. Please help me. I'm just stuck with that question." So in that case, uh, she has a priority. So the teacher will pause all the student questions and answer her question first, and then once she was free, she was go to her next class, or maybe she want to go home. After that, the all the four students questions can be paused and it can be resumed, and teacher will ask their remaining questions and answer them. So this is how high priority processes works in the preemptive scheduling. So it's a very nice example, and uh, it was a good example. Like nowadays it happened oftenly. So yeah, ladies first, that can be a scenario. That's why it comes a ladies first, because she has a high priority. So there's an example to demonstrate. uh, so we have the process A, B, C. So in that case, process A runs, and then here comes the process B, high priority. She interrupt, and the CPU runs their process, and then A process will be in the again in the ready queue. As you know that we have the ready queue and the running queue. So ready queue is where all the processes are waiting for their turn, and we have a running queue where the CPU is basically running their processes. So once a process A comes, it will be in ready queue. It will move to the running state. It will processes, but suddenly the process B interrupt. So the process A moves again to the ready queue, and the process B in a running queue. Once it will execute it, it will be a next process in the line would be a C, then C runs, then again process A already in a ready queue. So now it's turn to be in the ready queue from to running queue. So in that case, how its preemptive scheduling works. So this example is a very you can definitely you will understand from the the example I quote to you about the student and the teacher. So this is a difference between the preemptive and non-preemptive scheduling. So preemptive scheduling, the process A comes in the running state, and then the process 2 interrupts. So the process A again go to the ready queue, then again process A turns come and it will execute, then again process B interrupts, and then so this is how preemptive scheduling works. The same with the class of professor, and therefore male student, and there suddenly a girl came, so she has a high priority. And on the other hand, we have the non-preemptive scheduling, process A, process 1, and process 2. Once the process A finishes, then the process B, has a turn. So it will not be a interruption or anything else. Yeah, it can be a quantum, like maybe a process A can be, work for 2 and then move to another state, and then process 2, works for 2 seconds and then go to again process one. So this is a scheduling of non-preemptive scheduling. So, but there is no interruption in that. There is no high priority, first come first serve. So hope you understand the preemptive and non-preemptive scheduling. And in my next videos, I will explain more about the what are the core reasons for preemptive scheduling and how priority scheduling works. Like that, we have some algorithms which we use in the CPU scheduling. So we will discuss about in next video. So stay tuned for us for uh, informative videos. Please like, share, and subscribe for more informative videos. Thank you.